All right, welcome to our first workshop of winter quarter. We're going to cover file analysis. My name is Jerry. I'm a current cyber officer.
Hello, I'm Juliet. Oh, sorry. Hi, I'm Juliet, and I'm a cyber intern.
Hi, I'm Steph. I'm also a cyber officer.
And I'm Caolinn. I'm also a cyber intern.
And before we get started, a couple of general announcements. So unfortunately, you guys have probably all heard the news that UCLA is going to be online until January 28th. So that also means that all of Cyber's events will be online. So it's going to be, the workshops are going to be like this one on Zoom. And SciBeta Row signups are out. Oh, we should probably include the link to the slides in the chat. Can someone send that? But also, if you click on the link in the slides, you can sign up for SciBeta Row, which is our competitive CTF team. It's really beginner friendly. Don't be afraid to sign up. Just make sure to commit and attend CTFs and earn cool stuff. And lastly, POG.
Very important. Thank you. We're going to start off with a little bit about numeral systems, just a quick overview of three important ones: decimal, hexadecimal, and binary. Okay, so decimal is a base 10 system, hexadecimal is a base 16 system, and binary is a base 2 system. And what this basically means is, if you look at the table in the top right-hand corner, you'll see that like what you would typically think of as like the ones place, that's 10 to the 0 place. And in hexadecimal, that would be 16 to the 0 or 2 to the 0 for binary. Then you go to like the tens place, 10 to the 1, 16 to the 1, 2 to the 1, stuff like that. And in the middle table, you can see that there's a conversion table. So you'll notice that hex is pretty similar to decimal, just that 10 through 15 are the letters A through F instead of 10 through 15. And then the prefix 0x often will denote base 16. So if you see that, you can think of it as a hex number. So just two examples are at the bottom. So for example, if you had 0x and then 111, you can use the conversion tables that we've given on the slides. And if you add everything up, you should get 273 as your decimal number. Okay, cool. And that leads us to a bit about bytes. So computers operate in binary. They operate in numbers, zeros and ones. And in general, if you have 8 of these binary digits, which we call bits, you have 1 byte. So a byte is a single unit of digital info. And with a single byte, you can really represent a letter, a symbol, a number, although you're limited to the numbers 0 through 255, because if you have 8 different bits, the highest number you can possibly represent is 8 ones, and that is equivalent to 255 in decimal. And if you want more clarification, you can see an Ascii table. This kind of lists like the decimal, the hex, and like binary equivalents of different things. So for example, like if you wanted to represent the character A, if you look at the third column, the second row, the decimal equivalent is a 65 and hex is 41. Okay, and then for the main topic of today's workshop, we're talking about files. So file is a collection of bytes and it's stored as one unit. And there's a distinction between like the file contents itself as well as the metadata. So the metadata is what describes the file's info. So for example, maybe your data is like the picture of the cat, but your metadata is like the specific information, like when this image was created or how big this image is, or maybe like what day it was taken or edited and stuff like that. And then you also have something called the file format and the file extension. So the format, I like to think of it as it's a little bit more general or broad. It's how the data is stored as bytes, as well as how it's organized within a file. So if you have like a image format, file format, there's different extensions that can indicate that something is an image. So for example, the .png is one example. There's also like .jpeg and stuff like that. Those extensions tell you that we have a file format of an image. Okay, and you can actually look at metadata of different files. If you're on a Mac, you can just click on the file, right click on the file, and then if you click Get Info, If you go ahead and click on the slide again, you'll see that after clicking Get Info, some more information pops up. And so you have your original file and then your metadata, some stuff like, where it's created, when it was modified. And the same thing is possible on Windows. You just click on the file and click Properties. Okay, cool. And then this leads us to something called magic bytes or magic numbers. These are specific byte sequences that computers will use to identify a file's formats. Usually they are at the beginning of a file's bytes. And basically once you see these, you can tell, oh, this is a JPEG or this is a TXT file. And a little hint for later on, our challenges later on, is that if you change the magic bytes, it might make the file's contents like you can't open the file, or it might make the file contents seem really like gibberish. But if you do know what you're looking at, you can decipher that the specific file type that it is and possibly recover the file. So this is just a list of some of the most common files as well as their magic bytes. If you wanted to learn more, you could click on the, go to the tiny URL, which is basically the Wikipedia page. And it has a really, really long list of different hex signatures and their descriptions and their file extensions. And then if you're curious on how do you look at these bytes, how do you find out what the magic bytes are, you can actually use a hex editor to open a picture, a file of any sort. And so if you have a Windows, there's like HXD, there's hexdump and stuff like that. On, for example, I did this on the terminal for a Mac computer. But if you type hexdump and then your file name, so for this example, I used a .png. If you go ahead and click on the slide again, you'll see that the magic bytes are listed at the very top at offset 0, so like at the beginning of the file. And a fun fact is that like the second, third, and fourth bytes are actually equivalent to the spelling of PNG. So if you find like these little magic bytes that we showed on the previous slide, then you can match them and be able to identify what type of file it is.
All right, so now we're going to go over some very common file formats. One of the types of files you'll see the most often are archive files, namely zip files. A zip file is an archive file composed of compressed files and the corresponding metadata. It's also important to know that there are different types of compression methods, but the most common one is deflate. So zip files have three main parts. First, there are the entries, which are organized with the local file header, which is specifications regarding the file. Then it's followed by the file data, which is the data that was in the file, and then the data description, which is optional, but it just adds certain things about the file. Next, there's the central directory, which records all of the entries. So all those entries that are organized, like I just explained, will be in the central directory. And then there's the end of central directory, which is like the end of file kind of for zip files. There are also some format specifications and decryption records in there, but those are the three main parts of a zip file. Another cool thing about zip files is that since they're widely used, there are some other formats that use the zip file format, like the Office Open XML file formats, which is essentially a zip file for XML files. This means that Office files like Word documents, PowerPoints, and other ones can be unzipped just like any other zip file. It can come in handy since embedded and linked information are all supported by these file formats. So it gives a lot of possibility to hide data within the files. Some other interesting file formats to look at are PDF, audio, and video files. PDF files are formatted using objects, which means you can essentially parse the contents of the PDF file. So the place to look is then the body and the table that references all the objects in the body. You can essentially then bin walk through a PDF file. Then there's also video files, which are containers. They kind of include the video, audio, and metadata, and compose them all together to create the video. One of the more common formats for this is the MP4 file. In particular, MP4s are organized by boxes, and each of these boxes compose different pieces of data. And the most interesting for one would be the box that contains the metadata, the move box. since the metadata can include anything from the date, the artist, and the subtitles, and you can insert payloads into the box.
So basically what file carving is it allows you to extract files that could be lost without the assistance of the file system itself. So we're basically going around what the file system is. And so hypotheticals where this would be useful is when there's accidentally or purposely deleted files. If files are corrupted, so there's damaged files, or there's files in unallocated space with no data. And so the basic process of file carving is scanning the raw bytes and then putting the mugs in order using the headers and footers. And so very useful tools for file carving would be binwalk or DD, where DD is data dump. And then some more on binwalk. So just to install it, I have a Linux machine, so these are going to be Linux commands, FYI. So sudo apt install binwalk, that installs it. And then the most useful binwalk command would be binwalk-e, and then you would put the file that you're extracting. And then if all else fails, that doesn't work, binwalk-help, it will literally give you every single command you could possibly need. And later on, Jerry's going to do a nice demo for us about binwalk to go more in depth. And so now some background on bash. So bash is a shell that surrounds the operating system kernel. The original shell was the born shell in 1979, and now it's the bash, which stands for the born again shell. It's the Unix machine default, so Linux machines. And if you want to know which shell your operating system is working on, just type in the terminal which $shell. Mine has bash, obviously. And it's also a programming language. So to the right, we have a little clippet of Hello World, the most important program ever written. And so instead of like Python would be .py, bash would be .sh. And so some useful bash commands for file carving specifically is file, which helps you determine the file type, hexdump, which displays the contents in ASCII, decimal, hexadecimal, or octal, and strings. Strings will be super useful because it prints all the strings in the file. So if there's hidden text in a file or in an image and you do strings on that, you'll get a list of all of the characters. It is JSON born. And then some basic bash commands, ls, cd, cat, man, mv, vim, nano, vi, pick your text editor, grep, and then clear. So any command you could possibly need. You can also search for commands, and the internet is a very infinite place.
All right, now that we've talked about files, we're going to talk about what holds the files, which are file systems. And file systems are basically a tree structure that contains files and other file systems. So you can think of it as like a folder in your hard disk, but it's shaped like a tree. So if you look on the right, kind of has, if you flip the image upside down, you can imagine there's roots and then it's branching out into trees. And then each subtree is like something that's inside the folder. So inside the slash folder, which is usually like the root file system, you have the home folder, the etc folder, etc. And then something that's kind of interesting is that files that begin with a dot, and this files includes folders as well, are hidden. So for example, if you've ever tried to initialize a Git repo, it creates a .git folder. And if you just do normal like ls, which displays the contents of the file, you won't be able to see it. You have to do ls-a, which shows all the files, including the hidden ones. And the reason why this is kind of interesting. So there's two special file systems that you can get to within any file system, which are dot, which is the current file system, and dot, which is the parent file system. So for example, if let's say you're in this JSON folder, the dot would be JSON, dot would be home, so it's parent. And then when they were programming it, they didn't want to see dot and dot dot every time you asked the computer, like, what files are in this file system? So they just said anything that like the first character is a dot, we won't show. So as a consequence, all the files and all the folders that begin with dot are now hidden. Some examples of file systems. So different OSs use different file systems. For example, Windows uses NTFS. It used to use a file system called FAT, which I found was kind of interesting. And then Linux uses ext4. This is like the 4th version. It began with ext1 and then 2, 3, and then 4. And Mac OS uses APFS, which is like the Apple file system. And the reason why we're talking about this is that in Linux, everything in Linux is a file. So technically, you can think of file systems as part of file analysis. And then one really interesting command that you can use to see the structure of a file system is the tree command. So you can do brew install tree on Mac if you have homebrew, or if you're on Linux, you have sudo apt install tree. And it's really similar to ls. So for example, I'm in this test folder. If I just do tree without any arguments, it just assumes that you're doing tree of the current one. So you can see there's one file, hello.txt, in this folder. If you do tree-a, which is kind of like ls-a, that shows all the hidden files, you can see there's a dot hidden, which is a file, and a dot hidden directory, which is a directory. And within that, there's some cyber secrets. So maybe in one of your challenges, you might need to find some hidden files using -a. And now I'll go through a quick demo of Bash and Binwalk. So let me go to here. Hopefully everyone can see this. So I'm in an example folder. So if I just do ls, you can see there's 3 files in here, blank.dog.jpg and thumbs.png. You can also do tree to see it in kind of like a tree structure. There's no hidden files, I think. Oh, other than like dot and dot dot. And you can also do tree-a. So let's take a look at this. We're first going to take a look at dog.jpg. So something that you can do, I think might be only Mac OS, is you can do the open command. So if you open dog.jpg, it opens up a picture of a really cute dog and some other probably important person next to the cute dog. So that's kind of cool. You can also open like thumbs.png, and that opens up Josh's face with a thumb. It's kind of cool as well. But if you try to open blank, you can see that it renders as text because blank has no file extension. The others have .jpg, .png. This one has no file extension. So by default, it opens it as like ASCII text. You can see that this is like completely unreadable. But something that might be interesting is you see the first, or I guess, I don't know if people can see this because this is kind of small, but the first 4 characters, like the second, third, and fourth characters are P, N, and G. And if you recall from, I think Juliet mentioned this earlier, the magic bytes of P and G are like the second, third, and fourth bytes are P, N, and G. So maybe to see this clearer, you can do hex dump blank. So that was a lot. So we can just do head, so which is like the beginning of it. So you can see 89, 50, 9E, and 47, which are like this non-ASCII character, and then P, N, and G. So now that we know this is a PNG file, we can rename it. So MV renames it. So let's rename blank to blank.png. And then now we can open it. So open blank.png, and now, wow, it's the ACM Cyber logo. So that's something that you can do. So now the other thing I wanted to show was Binwalk. So as Caolinn mentioned, Binwalk is a really useful tool for extracting hidden files. So Binwalk --help, it lists out a bunch of things that it can do. We're only interested in like a small subsection. So the one that seems suspicious to me is Josh's thumbs up picture. Like why does he have his thumbs up? So let's investigate it a little. If we just do binwalk thumbs.png, we can see that it runs. And then it shows you that there's two PNG images in here actually. There's one at offset 0 and one at offset 4223210. So how would we extract that? So one thing that Caolinn mentioned was -e. Another way is dd. So I'm going to use dd. So if we do binwalk and then --dd, and then this flag, you have to input the file extension. So we know it's PNG, but you can also do .star, which means like all the extensions. And then if you just do thumbs.png, it'll extract these two PNGs. So now if we do ls, you can see there's a thumbs.png extracted. You can go into this and then see there's two images. If you open the first one, actually you probably need to rename these to .png, and then this one to I'm too lazy to type that, so second.png. So open 0.png, it opens up the first image of Josh, and then let's see what the second one has. So if you open that one, oh my God, it's another Josh with his thumbs up. Yeah, so that's kind of cool. The reason why we can only see the first one when there's two images in that is like the computer goes through and PNG has like a NPNG section. It's kind of like the opposite of Magic Bytes. Like Magic Bytes tell you at the beginning what file it is. At the very end of the file, it also tells you where the file stops. So if you have things past where the file stops, then the computer is only going to read up to there. So with binwalk, you can see if there's anything beyond that. So this is an example of file carving. And then one last thing that I wanted to show was the tree command. So if we do git init, which creates a Git repository, and then we can do, sorry, it keeps on going to the bottom of my screen and I can't see there. Okay, so if we do tree, actually, we should probably go back in the, actually, I'll just stay in here. So if we do tree, we can only see two things, but that's because Git is a hidden repo, hidden file system. So if you do tree -a, we can see like that Git init created all of this. And if you want to learn more about like what each of these things are, I think CS35L talks about this a lot. Yeah, so you'll have fun learning about this in CS35L if you haven't taken that. Yeah, that's basically it for what I wanted to show. Okay, so we'll go back to the slides. I think that should be the end of our workshop. Thank you guys for attending. We have challenges up on acmcyber.com. So if you want to go to acmcyber.com, register for account. We have a lot of fun challenges that you can solve and get points on, and then show off how smart you are on the smartboard or on the scoreboard. And yeah, this is our attendance code at filing my names. Thank you guys for coming. Wow, there's so much stuff in the chat.